Dear students, the week ending 3 April 2020 was a week where we devoted our time to solving equations. So what we have here, I've summarized basically all the types of equations that you were solving, namely rational equations, quadratic equations, simultaneous equations, and polynomials. I have found it necessary for me to go with you on each of these equations so that we at least get to know how to solve each of them. So in this particular tutorial, I'm going to focus mainly on rational equations, how to solve rational equations. So a rational equation is shown. You can see that when we have a ratio of terms, an equation with a rational term is called a rational equation. For example, x minus 3 over x plus 4 is simply a ratio there. So that is a rational equation. So what we have here is a list of rational equations, and I want us to go through and demonstrate how to solve each of the rational equations. So we are going to start with this one, 5 over x minus 5 over 6 is equal to 5 over 3, and we want to demonstrate how to solve this one. How do we go about it? The idea is to remove the terms in the denominator, but we don't just throw the terms away. So how do we remove the terms? We need to multiply each of the term in the equation by what we call the LCM. So what is the LCM? The LCM stands for lowest common multiple. So the lowest common multiple is that term which can be divided by each of the terms in the denominator. So in this case, I want you to take note that 6x is our lowest common multiple. You see, 6x can be divided by both 3, by 6, and by x. We also have the 12x. It is a common multiple, but it's not lowest because it comes after 6x. We can also have 18x. All these are divided by the terms on the denominator, but they are not lowest. So we will divide by this one. We will multiply throughout by this one. So let's demonstrate how to solve this. So we will have 6x, we multiply by 5 over x, minus 6x multiplied by 5 over x. 5 over 6 is equal to 6x multiplied by 5 over 3. See what we've done? So this we can divide. We have 30 is equal to, you can see, 30 minus 5x is equal to, can divide there to get our 2x times 5, that will give us 10x. So we collect our terms, so we'll have 30 is equal to 5x goes the other side, that will be 15x. So we can divide throughout by 15 to get our x is equal to 2. Simple, very simple and straightforward. So let's move on to solve the next one, which is 6 over x minus 3 is equal to, it's 6 over x minus 3 plus 9 is equal to minus 3 over x minus 3. So you can see again 9 is as good as 9 over 1. So we can multiply throughout by x minus 3, x minus 3. So we'll have x minus 3 multiplied by 6 over x minus 3 plus 9 multiplied by x minus 3 is equal to minus 3 over x minus 3 multiplied by x minus 3. So this will cancel, we get 6, plus here we can expand, 9x minus 27 is equal to minus 3. So we collect like terms, in other words those terms with x. So we will have 9x is equal to minus 3 plus 27. Take note that when the term crosses an equal sign, it changes sign. So minus 6. 9x is equal to, you can use your calculator, but I think this is mental. You can get your 8 in. Then you divide by 9 throughout to get x is equal to 2. X is equal to 2. After dividing throughout, how simple it is really to deal with the rational equation. Very easy. Let me return again so that you can see. So x minus 3 is our lowest common multiple. So you multiply by that one. But I want you to take note that even in the first equation, assuming that we made a mistake and we multiply by 12x, we'll still get the same answer. But the only problem is that we would unnecessarily deal with so big numbers, which we could have avoided by using the correct LCM. So ladies and gentlemen, I want you to practice how to find the lowest common multiple for algebraic terms. I will not demonstrate here, but basically that is exactly what we are doing when we are solving rational equations. Now I want us to move on. And deal with the part A, which is x minus 6 over x minus 5 is equal to x minus 1 over x plus 5. This is straightforward. The LCM of these two terms that I've highlighted here, our denominator terms, is actually the product of the terms x minus 5, x plus 5. This is our LCM. That is our LCM. Sorry. So if that is our LCM, we multiply by that throughout. So we'll have x minus 5, x plus 5, multiplied by x minus 6 over x minus 5 is equal to x minus 1 over x plus 5 multiplied by x minus 5 multiplied by x plus 5. You see what we are doing? Each term must be multiplied. So this, we can see this cancels and this cancels. This cancels and that cancels. So we will remain with x plus 5 multiplied by x minus 6 is equal to x minus 1 multiplied by x minus 5. Straightforward. So what are we going to do? We need to expand the denominator, the brackets. We need to clear off the brackets. So we know that expanding means this we have covered. Each term, x must multiply each term in the next bracket, and also 5 must multiply each term, like that one. So we will have our x squared minus 6x plus 5x minus 30 equal to x squared minus 5x minus x plus 5. I'm sure you can see this is just direct expansion. If you don't see what is happening, try to go through expansion again so that you are able to follow nicely without any challenges here. Now from here we need to collect like terms. Terms in x squared, we put them together. Let me just show you here. But take note that when x squared comes this side, it becomes negative. Then I will say minus 6x plus 5x this plus 5x, this one. Then we take also this one, the other side, it becomes plus 5x plus another x, because this x is coming also, is equal to, when 30 goes the other side, it becomes 30 plus 30 plus 5. You can see this cancels off, and you will remain with the minus 6 plus 5, that is minus x, plus the 5x, that is the 4x plus x. All the terms in x will give us 5x is equal to 35. So you can divide by 5, we can divide by 5 to give us what? X is equal to 7. Oh, sorry. We are simply dividing by 5. So 5x is equal to 35. We divide by 5 to get our x is equal to 7. Straightforward, ladies and gentlemen. This is very simple. So the trick behind solving rational equations is just to appreciate that you need to multiply, to remove the denominator by multiplying by the lowest common multiple of that denominator. That is a very key aspect. Lowest common multiple. Let me go through part B. Part B, I think there is something that we are going to illustrate there in part B. You can see, let me put my paper. So what do we have? We have 5 over 2x minus 3 is equal to 5 over x squared minus 1 plus 5 over 3x minus 3. Ladies and gentlemen, I want you to take note that to find the LCM of these terms, when they are like that, it is not just straightforward. You can't see. So what you need to do is to factorize this. We factorize that. We factorize this one. So what I'm going to do with you here is to demonstrate how to find that LCM. So we will have our 5 over 2. Oh, sorry. This is supposed to be 2. This is supposed to be 2. So we factor out our 2x minus 1. You see what I'm factorizing is equal to 5. This one is simply the difference of 2 squares. So it will be x minus 1, x plus 1. I'm sure we did this part when we factorize that one. Is the difference of 2 squares. X squared minus 1 squared. So when we are factorizing this one, the difference of the square of x and the square of 1. So we just write it like this. In one bracket we add, in another bracket we subtract. So it does not matter. You can start with x minus 1, the other side. That one I think it's, So plus 5 over 3 x minus 3. X minus 1, sorry. We have factored out our 3. Now let me demonstrate here how we are finding the LCM. So let us rewrite all this. 2x minus 1 as a product of prime factors can be written as 2 times x minus 1. You see? That is what it means. Then x minus 1 by x minus 1 is equal to x minus 1 multiplied by x minus 1. I'm just demonstrating this so that you see where I'm getting this. 3x minus 1 is equal to 3 times x minus 1. So to find the LCM, the lowest common multiple, you see in terms of numbers, LCM will be equal to, you take these 2, you put it here. Then you take this 3, you put it here. Now x minus 1, where do we have many x minus 1? This one is supposed to be plus 1. Remember? It's supposed to be plus 1 because it's for this one. It's supposed to be plus, yes. Sorry for that. So here we take x minus 1, but we don't take everything. We just take it once. So multiply by x minus 1. So which means x minus 1 is covering for all the x minus 1 that we are seeing. So for x plus 1, we take it also once, x plus 1. So our LCM is actually 6, x minus 1 multiplied by x plus 1. This is what we are going to multiply with each term. Each term will be multiplied by this LCM. But I want you to revisit a bit the work on how to find the lowest common multiple. Here really it is assumed that you understand how to find the lowest common multiple. Now, how do we proceed? We multiply each term by this. So we will have our 6 x minus 1 x plus 1 multiplied by 5 over 2 x minus 1. I put that bracket. You see what is happening? I'm multiplying by that one. Is equal to 6 x minus 1 x plus 1 multiplied by 5 over x minus 1 x plus 1. I'll put my big bracket. You can see, use your brackets properly. Plus 6 x minus 1 x plus 1 times 5 over 3 bracket x minus 1, and I'll put my big bracket here. You see what we have now? So with that one, this cancels with that one, and our 2 will cancel into there to give us 3. So we'll have 15 x plus 1. I want you to see that one. This will be equal to, this cancels with that one. So that will remain with 6 times 5, which will be 30, plus, now this cancels x minus 1 with another x minus 1. So 3 will into here will give us 2. 3 into 6 will give us 2. So 2 times 5, 2 times 5 will give us 10. 10 times x plus 1, like that one. So we can still collect like terms and simplify. So we'll have 15x plus 15 is equal to 30 plus 10x plus 10. Let's collect everything with the x. 10x comes the other side. We will have, but it will subtract. Let me just write minus 10x so that you see what is happening here. Is equal to 30 plus 10 minus 15. You see 15 is going the other side, so it will be minus. So we will have here 5x is equal to 40 minus 15, that should be 25. You can divide by 5 throughout. So we'll get x is equal to 5. Ladies and gentlemen, check how simple this work is. So what is the trick? The trick, you must be able to find the lowest common multiple. To find the lowest common multiple. Now, the last part, I will leave it for you to do it. Just do the last part. I will leave it. So you need to factorize this and determine the lowest common multiple and do exactly what we were doing. and solve. But what is the lowest common multiple for this expression? Let me just give you the LCM. I can see it already, so I want to give this one to you so that you can use it, but convince yourself how I am getting this LCM. Now, before I conclude this one, let me assist you basically on how to find the LCM. But what I'm going to do, I will use simple numbers. Let me assume you are given 12, you are given 6, and you are given 24, and you are asked to find the LCM of these numbers. The same way we find the LCM for these numbers is the same way we find the LCM of, for example, x plus 3, x minus 2, for example. Suppose you have a term like that, and x plus 3, x, let me make this squared, x plus 2, and also x plus 2 squared x minus 1. How do you find the LCM of these terms? LCM, because this is important, so that when these are presented as the denominator of a rational equation, you must not have problems. So how do we go about finding the LCM? You need to express the numbers as a product of their prime factors. 12 can be written as 2 multiplied by 3. Is it 2? 2 multiplied by 2 multiplied by 3. You see, 2 is a prime number. So for 6, you can write it as 2 times 3. 24 can be written as 2 times 2 times 2 times 3. Sorry, let me put this one up for you to see. So it's 2 times 2 times 2 times 3. You express each number as a product of its prime factor. So I did not write 2 times 12 because 12 is not a prime factor. 2 times 12 is 24, but that is not expressing 24 as a product of prime factors. So that's why I'm writing 2 times 2 times 2 times 3. So what you do to find the LCM now, once you have expressed as a product of its prime factors, where do we have many 2's? Where do we have many 2's? We have them there. In other words, here there are 2, here it's only 1, 2, here there are 3. So I will write only this to represent all the other 2's. So it will be 2 times 2 times 2. Where do we have many 3's? 3's appear the same number of times in all cases. So I just write once. I can take it, just 1 3 will be enough. So this is equal to 2 times 2, that's 4 times 2, that's 8 times 3, that's 24. Indeed, this is the smallest number which can be divided by both 12, 6, and 24. That is the method. So why am I demonstrating this method? Because it is key when it comes to your ability to solve a rational equation. Because the rational part, the denominator part, you must be able to establish the lowest common multiple. Now, fortunately or unfortunately, we normally deal with this. So I want you to post on our group, all the various platforms, WhatsApp group, wherever you feel comfortable, how have you managed to find the LCM of this? That work is very, very important. So, ladies and gentlemen, it was nice presenting to you the issue of rational equations. The whole idea is to be able to find the LCM for your denominator, multiply throughout each term in the equation, multiply each term by the LCM in order to make sure that you clear off the what? The denominator term, so that you have nothing on the denominator. Then once you have that, collect like terms and solve as required. We are going to meet in the next segment where we are going to talk about the quadratic equations. You see, we have covered rational equations. So I'm going to summarize the quadratic equations, the various methods of solving quadratic equation, that is factorization, completing the square and quadratic formula. And in the next segment also we cover the remaining equations. Thank you very much.